All right. So yesterday in class, we talked about this whole concept of a quadratic formula in vertex form, right? Where we had a times x minus h all squared plus some k. We said, we said what a does. We said x minus h, it moves it left to right. Then we say k moves it up or down. So we're going to apply this to part two, okay? So you should have attempted these by now. So it's just checking your answers. Okay. But the first one says, write an equation for each problem below. Use a second representation to check your equation. So when they talk about representation, it could be a graph, a table, and everything like that. So it says the area of a square with side length x, where each side length is decreased by 3, and the area is multiplied by 2, and then the square, 4 square units are added to the area. So if you think about what we have here, we have this initial square that we've talked about, where each side is x. And it's saying where the side length is decreased by 3. So we're cutting this off now by 3. Okay, so what is this new area going to be? Well, now this side becomes x minus 3. All right, which means we're going to cut 3 off here too. So this side is going to be x minus 3. So now the new area is x minus 3 all squared because it's side times side. Now, we're going to take and multiply this area by 2, and then we're going to add 4 square units to it at the end. Okay, and this should be the equation you get. So this diagram is one representation, this equation is another. You could graph this parabola, or you can get the table of values. So number 2, one representation would be to write an equation for this, okay? And if we write an equation for it, the first thing we need is the vertex, which is at 3, -1. The vertex is at 3, -1. Remember, we do a times x minus h all squared plus some k, and your vertex is at hk. So if our vertex is at 3, -1, right, our function is going to be f of x equals x minus 3 all squared minus 1. The only thing you have to keep in mind here, right, is if you put this in your calculator, does it match up to this graph or this table, right? If I graph the parent function like such, so we have this. It may be tough to see, but what happens is this is a little wider than this. So what that tells us is there's probably some a involved other than 1. So what could we do to find it? If I look here, in the parent function, you move right 1, you go up 1. Then you go over 1, up 3. Right? Now, there is something that we're going to talk about, down the road. But what I notice here is I go over 1, up 2. Right? So what that tells me is my a value is 2. Okay, if I went over 1, up a half, my a would be a half. If I went over 1, up 10, my a would be 10. This here will match up with that graph. Okay, will you see a lot like that? Not right now. Down the road you will. So we'll get better at them. So don't freak out yet. All right, now the next example. Now, one thing you could do, one representation would be to graph this, plot all these points and see what you get. All right, I'm not going to do that because I know you guys know how to plot points and do that. But the one I want to focus on is writing the function, right? I want to write this function here, f of x equals a times x minus h all squared plus some k. In order to do that, I need the vertex, okay? So again, first thing we do is we look at this table for symmetry, and we try to locate the middle. So if I look here, I see a -1 here, a -1 here. I see a 2 here, a 2 here. I see a 7 here, a 7 here. So what that tells me is this here is my vertex. So my vertex is at -1, -2. So what does that mean? Now I can go ahead and say f of x equals, it's going to be x minus -1 all squared. And when I subtract the negative, what's it become? Plus, and then all minus 2. So one way to clean it up would be to write it as x plus 1 all squared minus 2. Now we could check for an a here, because if I technically look at this, right, I'm at -1, -2. And if I plot the points to the left and right, I have 0, -1, -2, -1. And if you look, what happened? It went over 1, up 1. So I know a has to be 1, and I don't have to write that in. Okay? And again, we're going to explain that part as we move along. Okay, number 3. Same thing. I can create a table of values here if I wanted to, right? Find all of these nice points and create a table. Right? I can make a table of values here. But let's just start with the vertex, which is at -3, 4. So right away, f of x is equal to x minus -3. And when I subtract -3, right, I bling bling it, so it becomes +3 all squared. And then I have my +4. Now, when you look at it, I will let you guess right now, right? But if I look, I went over 1, down about how much? I went down about a half, okay? So in this case, -1/2. It's negative because if you see this is reflected, so a is negative, it's going to be about -1/2, okay? So I could create the table also, putting the vertex in the middle. So -3, 4. Here's a nice point here, which is at -1. What is that, about -2? Then I can say another nice point is here, and -5 on -2. So I still see that symmetry. The same distance to the left and right, same distance up. Okay, so you can make your table. If you plug this in, that should match up. Okay, number 4 is done. So let's move on to this here. So in number 5, it says graph each equation without using technology. Be sure you have the exact vertex and at least 2 correct points on either side. So that a part is going to come into play here. If I wanted to graph -x² plus 3, all right. All right, so I'm going to step away from that task, and I'm just going to show all of the examples. So number 5, you're asked to graph f of x is equal to -x² plus 3. Okay, I advise you guys find graph paper if you don't have it, and do it there. Now, the most important part about finding or graphing a parabola is knowing the vertex. So when I look here, if I'm not adding anything inside parentheses, right, I know my x-coordinate of the vertex is 0, my y-coordinate is 3. Now, since a is negative, I know it's going to open down, okay? So I'm going to go ahead and plot 0, 3 first. Now, if you look, right, at the directions say, you know, make sure to have points on either side. We want to be accurate. And there is going to be a non-calculator portion of the quiz, so you need to know this. right? So what we do to graph this now is we use what we call 1a, 3a, 5a. And it all goes back to what I talked about when I showed you the parent function, the 1a, 3a, 5a. Well, in this case, what is the value of a? If you don't see it, we know it's 1. So if a is negative 1, 1 times negative 1 is negative 1. 3 times negative 1 is negative 3. And 5 times negative 1 is negative 5. Well, these are what we call steps, right? If we move over, if we go right 1, right, then we're going to go down 1. Next one, we're going to go right 1, down 3. Then we're going to go right 1, down 5. And then basically you duplicate the process on the left. So I start at the vertex. I go right 1, down 1. From this point, now I'm going to go right 1, down 3. Then from this point, I'm going to go right 1, down 1, 2, 3, 4, 5. And I'm going to duplicate it because they're symmetrical on the left side. I move over 1 each time. And now, if you graph this in your calculator, that's what your parabola would look like. Okay? It's actually much faster to do it by hand than it is on the calculator. So the next one, g of x equals x plus 2 all squared minus 5. So again, what's the vertex here? The vertex is at negative 2, negative 5, right? Remember, it's always the opposite of what's inside the parentheses. A in this case is 1. So our 1a is 1 times 1, which is 1. 3a is going to be 3. 5a is 5. So I plot the vertex. Negative 2, negative 5. And from here now, I'm going to go right 1, up 1. Right 1, up 3. And then right 1, up 5. Right 1, up 1. Right 1, up 3. Right 1, up 1, 2, 3, 4, 5. And then I duplicate it on the left side. And I graph my parabola. Okay? Hopefully this is pretty straightforward for you. Number 7, we have 3 times x minus 1 all squared plus 2. And this is h of x. Okay, that's just the name of it. There's nothing else but the name. So the vertex here, where is it at? Well, the opposite of negative 1 is 1, and then positive 2. But in this case, a is 3, so 1a is 1 times 3, which is 3. 3a is 3 times 3, which is 9. 5a would be 5 times 3, which is 15. So I plot the vertex 1, 2. Then from here, now I'm going to go right 1, up 3. So right 1, up 1, 2, 3. Now from here, I'm going to go right 1, up 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I'm going to run off, so I'll just end up duplicating these two. That's about it. And as you should notice, shouldn't this be very narrow in comparison to the parent function? Yes. Okay, so that's how we use the vertex and the value of a to graph them by hand very quickly. So now, going back to number 8 on the task, what is the point? What is the vertex point of the parabola? Well, that is HK. What is the equation for the line of symmetry? That is always x equals h, because remember, it's the x coordinate of the vertex. How can you tell if it opens up or down? If a is positive, it opens up. If a is negative, opens down. And the dilation, meaning does it get wider or narrower? We look at a, and we've discussed that in the past. Doesn't matter in which order the transformations are done. Technically, yes, but we'll talk about that more in person. All right, get the ready, set, and go problems done, and have a good weekend.